According to Wiggins, there are 12 main steps in inquiry in mathematics. Step number 1, begin with a hook problem. Next, introduce essential questions. From there, preview the culminating performance task. Step number 4, provide direct instruction. Next, provide practice on the basics. From there, provide opportunities for further discussion. Number 7, provide an application task. Then lead a whole class discussion. Number 9, provide a small group application. Number 10, revisit the original unit hook problem. Then you can assign the final performance task. And then number 12, the last step, gives students opportunities to reflect on the unit's essential questions. With any 12-step program, we found challenges. So many outcomes, so little time. Will students be ready for the provincial exam? Can the essential questions be engaging all the time? Can we be sure all outcomes are being met? Planning in advance becomes a challenge because lots of time is required to get through each step for each outcome. Is it worth it to work through these challenges? When it comes to questions in math-based inquiry, we focused on two types: essential and engaging. Questions can be both essential and engaging, but it is important that questions aren't just engaging. With so many outcomes, what can we do to meet them all? Using the number sense unit, we can show how to prioritize the outcomes by importance. What do students need to know for 40 days, 40 months, 40 years? By taking all the outcomes, we can pair or group the outcomes together and decide which are coaching outcomes, 40-day outcomes, and which are game day, 40-month or 40-year outcomes. Game day outcomes are the ones that will use the coaching outcomes to be met and will be evaluated in summative assessments. This helps to make the many outcomes more manageable. In the number sense unit, we end up with 3 game day outcomes supported by 3 coaching outcomes. The understanding by design concept shows us how to take a single outcome and determine acceptable evidence for meeting that outcome using an effective and essential question. For example, 9.n.6 is determine an approximate square root of positive rational numbers that are non-perfect squares. To meet the outcome, students will need to understand that every non-perfect square will fall between 2 perfect squares. To understand, students will need to consider such questions as: how can we use perfect squares to estimate and justify non-perfect squares? To understand, students will need to know what a non-perfect square and a rational number are. Students will need to be able to estimate, be able to determine an acceptable approximation, and be able to justify their answer. Once we've determined desired results, we must plan assessment. Using Bloom's words, we can figure out which level each outcome matches. Words such as model, explain, determine, and demonstrate fit into the various levels of Bloom's as shown. The levels determine the type of assessment. For example, knowledge and comprehension can be assessed using the traditional quiz or test. Products can be assessed using a model or diorama. Once assessments are determined, each learning experience can be planned.